Okay, today we're doing bonus project 1, maximum stress, maximum deflection, and cantilever beam. So we got all the dimensions right here, we got the Young's modulus, we got the shear's modulus. So we'll find the maximum stress in ANSYS and the maximum deflection. Okay, first we're going to go to SolidWorks and... what? First we're going to go to SolidWorks and we're going to make the beam. So we're going to sketch, smart dimension, we're going to do the, it doesn't really matter, but I'm going to do the front plane. And then I'm going to create a rectangle. Actually, probably should change that to millimeters. So I'm going to need to do a back arrow. Say smart dimensions. So this is going to want to be 0.1 meters. Okay. This one is going to be 0.2 meters. Okay. And then we can extrude that. So we're going to extrude it 2 meters. Okay. Make sure that looks like it's what it's supposed to. Okay, now we're going to save that as a stepped file. So I'm going to do that. Thanks to credit. I'm going to do video. Okay, so part 2. Wait a minute. Okay, yeah, that's correct. Okay, so now we're going to go to Workbench. We're going to create a static, where is it? Static structure. Okay, so engineering data. I can't remember. Okay, yeah. New material. Let's do steel. It doesn't say, but we can change the properties. We can change the properties based on the shear modulus and Young's thing. I'm going to change these all to gigapascals. Then we're going to enter it 200 and then 76.9. Okay, that should show up in the corner right there. So we're going to go back to the project. We're going to not like click on it yet. We're going to import geometry. We're going to find that part that we just saved. And then once we get the check mark on there, we're going to go to model. My computer's kind of slow. It's funny as I don't even know if this program records audio. Okay. Okay. Still hasn't loaded completely. So we should be able to do everything in this window. There we go. So first I'm going to create a mesh. So I'm going to insert sizing, and then I'm going to do like a complete select. So So it's the big green one. And then I'm going to select the geometry. I want it to be hard. I don't know what that means, but in every experiment that I've had, it had to be like that. 0.05. Because you don't want it to be too fine that the program won't run it. Like if you have the free version, like I do. So I found that 0.05 works pretty good. Yeah, that's pretty good. Okay, so now for static structure, you can click on that. Then you're going to change it to face select. You're going to insert a fixed support right there. And then this side, you are going to insert a force. So it's going to be a magnitude of -2000. Click to change the direction. This is the part where I've had a little bit of trouble with, because you just gotta click around and at some point finally gives the right direction. Okay, I think I got it. Okay, let's apply that and solve that. So we're gonna see if I did it correctly. If I did correctly, there should be no errors, and there should be check marks. Okay, that's good. So we're going to insert a deformation. Directional toe. I think directional. Okay. Besides one of the force. This side. Okay. Directional force. Okay, that force is going the wrong direction. Let's edit that force. So I must have accidentally flipped it upside down when I was trying to fix it. It's funny, this is like one of the parts of the experiment that I've had the most trouble with. And it's not even like a hard part of it. It just doesn't make any sense why it wouldn't want to work for me. Get rid of that. Okay, I think that just worked. Okay, so if we do that, where's the... Okay, let's try total deformation just to see how that would look. Okay, yeah, total deformation is the one you want. So I'm going to delete the directional deformation. Wait. Yes, okay. Yes, because that's the exact number that I got with the by hand calculations. So by hand calculations, I got 0.0016. So that is basically the same. it's very close. That would be because the this is not an exact answer in this program. Okay, so now we want to insert a stress. So I can't remember which one I did. I think I did a maximum principal stress. Okay, 1.4276. Okay, and then let's just play around a little bit with these. I'll show you those. I'll show you the different ways. That one will not. Okay. So let's do the maximum principal stress. So that one looks pretty good. Okay. So let's go back to the problem. Okay. Find maximum stress, maximum deflection. Okay, we got the correct dimensions. We got. Okay, that should be all for the experiment. Okay. Results. Okay. So those are our graphs. Okay, so I'm gonna make sure we take a screenshot of those. These are helpful for when you are submitting the experiment. Documents, classes, for assignments, credit, video. This one will be a total information. This one will be next. Okay. So once you got those done, then you got to create a program. So this will be off the experiment.